Welcome to On Rails. This is the podcast where we dig into the technical decisions behind building and maintaining production Ruby on Rails apps. I'm your host, Robby Russell. In this episode, I'm joined by Rosa Gutiérrez, a principal programmer at 37 Signals. We talk about how our team tackled the growing complexity of background job management by building SolidQ, a database backend queuing system designed to replace their aging Resque setup. Rosa walks us through how they approach migrating live apps like Basecamp and Hey to this new system while still actively developing it. Quite a feat. We also explore how our team handles job retries, failures, recurring tasks, and long-running exports. Rosa shares practical strategies for debugging, simplifying job logic, and why she still leans on the one-off break task when the situation calls for it. Rosa joins us from Madrid, Spain. All right, check for your belongings. All aboard. Rosa, I have to ask, what keeps you, dare I say, on Rails?
That's a great question. If I'm being completely honest, it's mostly my teammates on my current job. They are so great that even if the framework wasn't as great, because it is, I will still be on Rails thanks to them.
I'm actually curious, how long have you been working with Ruby on Rails?
It's been now 11 years.
Where does that kind of place you on the version roadmap?
I started on Rails 3.
Okay.
I think Rails 4 was already out, or it was about to be released, I think. But the company where I started, they were still on Rails 3. So that was my first.
Was that Rails 3.0 getting to 3.2 and then getting up to Rails 4? Were you part of any of those early upgrade projects there then? Nope.
No, I never did any of those upgrades.
Okay. So what brings you here today is that I wanted to talk with you about SolidQ in particular. So I know that SolidQ was born out of your team at 37 Signals' decision to move away from Resque. And for anyone who hasn't read those several posts from David, we'll include links for those in the show notes. But from your perspective, what started to break down with Resque?
Yeah, the main reason was complexity. We have accumulated a lot of custom-made code and different gems that we built there at my company, forks of existing gems, all to manage different issues we have been hitting with Resque over the years. So when we started doing a new app and we wanted to use jobs in that new app and we checked, how do we have this set up in other apps? And David saw 7 different gems and a lot of different stuff that was very, very hard to wrap your head around. He said, what is this? This cannot be so complicated. So that's why we started SolidQ.
Interesting. And I'm curious, I talk about and it's a pretty common thing where over time an application you might have to fork your gem to do something that's special to especially if you're working on a larger platform or application with a lot of users or a lot of edge cases and things that are not maybe what most SaaS applications may or may not be encountering. And so I think it's interesting going through that process and being like, okay, what's a fresh take on these sorts of programming paradigms? And so I'm kind of curious, it sounded like that might have been a decision that might have come from David, but for you and in your role at the organization, what sort of things did you try to navigate? Were there a lot of edge cases that you were able to get rid of, or did you just try to account for that when SolidQ started getting developed?
Yeah, so when we started developing SolidQ, we basically took account of all the requirements, everything that we needed, that we knew we have to put together for Resque. So we built SolidQ with those requirements in mind already, thinking a lot about those specific things that we had to patch Resque for. So we started with that in mind. We also kept, a possibility that perhaps we could avoid some of the edge cases, some of the quirks we were patching Resque for. So we also kept that in mind, but mostly we were guided by those requirements.
Interesting. And did you go through the process we're going to build this new approach or new paradigm for the new application, or was it very much we're also going to use this opportunity to make this work in our existing applications?
Yeah, it was actually the existing application approach, because building it for a new application would probably have been not real. We wouldn't be sure because everything was new. We wouldn't have the volume in jobs, the problems, the edge cases. We wouldn't have anything there. So it wouldn't have been very realistic. So actually the approach was to start with an existing application. And for that, we chose Hey, our email service, for a couple of reasons. One, the code base was fairly recent, started in 2019, and we have kept it up to date with Rails. It had all the quirks that we had been seeing in Basecamp with jobs already. We were using the exact same 7 gems and using all of that. And the other reason was that we didn't want to try with Basecamp because it has lots and lots more users, and it's also our main app. Hey still is high criticality because it's email, but it wasn't as high criticality as Basecamp in the sense of it's higher criticality in some aspects like privacy and other stuff, but the jobs themselves, we had a little bit more margin there to deal with problems.
Out of curiosity, as someone that's used both Hey and Basecamp and different versions of Basecamp over the years, I'm curious what sorts of background jobs are you typically needing to think about from a user perspective? It's a lot of like CRUD interface type things. You're saving data, displaying data. What kind of behind the scenes stuff is typically happening? Is it like a lot of email notification type stuff, or
In Basecamp or in Hey?
in Basecamp?
Yeah, in Basecamp, so we have all the email notifications, of course. Then anything that's to do with bulk permissions, like when you add someone to an account, adding them to the projects, adding them, subscribing them to a lot of different recordings, all that happens in jobs. For example, processing all the stuff for the notifications themselves, not just sending them, but also say mentions, like scanning a text for mentions, that happens in a job as well. Processing actions that go in a cascade mode through hierarchies. Like, for example, you have a message with attachments and comments, and say you archive that message. So we propagate that through the hierarchies. Like, we propagate that in a job as well. Anything that's to do with deletions. We soft delete a lot of stuff, and we delete things in the background too.
Interesting. And for those listening, might be curious, like, well, you had patched Resque, might have been easier to try to get your patches into Resque, or versus like when does a team think like maybe we should just go build a new thing?
Yeah, that's a great question. I think Rescue, I'm not sure it's longer maintained, but maybe we could have forked it and do a new version. But it's actually a very, very old code base. It's really old. It supports any Ruby application. You don't need to use Rescue with Rails, which means it implements a bunch of the things that you now get with ActiveJob for free. So building a new system will allow to do something simpler that you could leverage ActiveJob. ActiveJob has a lot of things that a job queuing system need, like retrying, error handling, all the serialization, all that is built in ActiveJob. So that's great. But the main reason was actually that David wanted us to try to use a database instead of Redis. Resque use Redis as the backend. It's like Sidekick. They use Redis as the backend to store jobs, which is great. Like Redis has some data structure that are really, really well suited to this problem of having job queues. But since we had great success with Solid Cache, that was the first Solid gem that implemented a cache backend for Rails using a database and had been already running in production for one of our apps, and that was using a database. So David wanted to see if we could, use a database for this.
That's interesting. Yeah, I remember when that was coming out and when Solid Cache came out, I was like, oh, that's so interesting. I'm curious if in that scenario were you typically using the same database as for your cache, and then it was like like just other tables within the same as Basecamp's table, or did you have like a separate database that you were connecting to a different SQL database or something, or was it all just in the same one?
So for the cache, I think we started directly with a separate database. Kind of makes sense. Yeah, to have it separate, like the cache completely independent from the application. For Solid Queue, actually, we started with sharing the database, having everything together. One of the reasons was to have transactional integrity with jobs, so that you can't take advantage of, if you are doing any modifications in your data within a transaction and you want to enqueue your job within that transaction, that has certain advantages. Like you can roll back the whole thing if the job fails to enqueue, for example, or you don't need to worry that when the job gets enqueued, the data is not yet there because the job wouldn't be enqueued until the transaction where you are changing your data is committed. So it has some advantages. So that was something we sort of had in mind, and other ActiveJob backends that use the database, like GoodJob. GoodJob is a great example. We look a lot into that because it's a great piece of software. It also uses this, like by default, it uses the same database, and so it takes advantage of this transactional integrity. So we started there, and then life takes you other places, and we ended up with a separate database, and that is the default now and what we recommend. But we started that way.
Okay, I appreciate that, and I think that's helpful to get some context, and especially when you're like a local development environment and getting something running, and then when you're production, I was just like, how does that the advantage of like if you're talking and writing and reading from the same database versus like maybe you have it could be the same database server, but it might have a different database. So you can see like, well, this one's starting to get a little noisy. We might want to isolate that or something. But at least knowing that you have that flexibility there,
Yeah.
It does seem like with it, then you're also then as with like in Rails 8, like you don't have to necessarily like think about like spinning up and running another process in parallel in development, in your test environment, in your production environment, and how can we simplify that? And so I think I appreciate that about Rails kind of coming back and revisiting some of those kind of default assumptions over the years. And it's not a question of like we went from Memcache to Redis to back to the database. There you go. And I'm curious about, you mentioned like Sidekick at least once there, but were there anything about Sidekick or GoodJob that just didn't quite align with what you're looking there? Or was it just that primary factor of like, let's try to make this more Rails focused and we're going to take advantage of just the SQL database?
Yeah. So for Sidekick, it was obviously that it uses Redis. So it's also like we explicitly wanted to use a database. And for GoodJob, the problem was that it uses very specific features of Postgres that aren't available in SQLite and in MySQL. And we use MySQL. So we couldn't use that. So one thing we looked in the beginning was at whether perhaps we could make GoodJob compatible with MySQL as well and just contribute to GoodJob. But after I spent a few days looking into the code and getting familiar, it didn't seem feasible. It would feel like we are shoehorning MySQL there. Yeah, so for GoodJob, the problem was that GoodJob uses Postgres and it takes advantage of a few quite specific Postgres features. Like Postgres has a listen notify feature that is super, super handy to implement job queues. But MySQL and SQLite, they don't have this. So, and we use MySQL. And if we wanted to offer this for Rails, it will have to support the 3 official databases. So one thing we look at was to perhaps make GoodJob to support MySQL somehow. So I spent a few days looking into the code. It's really cool. It's really, really nice. But trying to see whether we could make it work with MySQL. We could generalize it. But it didn't seem that way. It seemed like we will be making it much, much worse. Like way before we launched SolidQ, I had the chance to meet the GoodJob creator, Ben Sheldon, in the first Rails World in Amsterdam. And I told him that I had been looking at the code and thinking whether we could support MySQL, and it didn't seem as a good idea. And he confirmed like that wasn't a good idea. So I was a bit relieved, like, yeah, we made the right call there.
That's great. What was your role in shaping the direction of SolidQ early on?
I was the main developer in charge of that. So it was my project. So I could do whatever. And I remember in the beginning, I look at all the existing gems and that and write down everything I found. And I did some tests as well. So I always wrote everything down for everyone to read. And I got great feedback from David, from Donald in my team, who was the author of Solid Cache. So they, gave their opinions. But ultimately, it was my decision.
Nice. One of the boldest parts of this is that, as you were mentioning that your team was migrating, was it Hey specifically to SolidQ while still building it, right? So
yeah.
What did that look like in practice? Like, how do you, you're running both systems in parallel at any point or?
Yeah, exactly. All the time running Resque and SolidQ together. So that's a great question. What I did was to start with the basics. Like, what's the most basic thing you can build, and think of the most basic thing that allows you to move some jobs. That was the requirement. Then first I chose which jobs to move first, which was the jobs that will have no user impact at all. And for that, I chose we call it incineration. That is the real deletion happening. So we soft delete everything. And usually, like for Hey, for example, I think we keep, when you cancel your account or when you delete an email, or most deletions are first put in for emails, they are put in the trash for 25 days, I think. And accounts are canceled. And once your subscription expire, it lasts for 30 days, I think, and then it cancel. And then 30 days after, we delete all the data. So there is always that period. So those jobs have no user impact. Like of course, we need to ensure, because in our privacy policy, we assure you that we're going to delete the data. But it's the case that if the job is delayed one day, it's not a problem.
Right.
So those were the jobs that I chose. We had quite a few different of those for soft deletion. And so for those, we needed basically being able to enqueue and run the jobs and scheduling them in the future as well. Because we do this is a very questionable pattern that I don't love, which is enqueuing a lot of jobs in the future to perform things that can be undone. But that's okay. That's how we were doing it, and we have to support scheduling jobs in the future anyway. So those were the main things we needed. So with that, I first built a prototype that just worked and did that. And then I moved those jobs. The nice thing about ActiveJob is that it allows you to define the queue adapter per job. So you can just move one job to a new adapter, and that's it. You just need to ensure you are running that. Of course, you are running both. What we did back then was that actually there was a pause in this migration that people, I haven't explained that to anyone yet, but the official version is that I was building Solid Queue for 18 months or so. But the truth was that in those 18 months, there were many months where I didn't touch Solid Queue at all. And it was because the building Solid Queue overlapped with our migration to Kamal in Hey as well. And that lasted quite some time. So I remember when I first started getting Solid Queue deployed at the same time as Resque, and that it was all Kubernetes still. We were still in the cloud using Kubernetes, and I remember doing that. But then, since they were moving also the app to Kamal, we decided, okay, maybe let's keep the moving pieces to a minimum and let's wait. Let's move this to Kamal first, exit the cloud, and then when the dust had settled, then we start moving to Solid Queue. So I remember I took a pause from the project. I completely stopped and I worked in other stuff, completely unrelated stuff. And a few months after, I took it back, adding different VMs where you deploy the app and you run Solid Queue using Kamal is super simple. So in the end, it was nice.
Right.
We didn't have to do complicated Helm charts and stuff. So having both Resque and Solid Queue running together was very simple.
I think for those listening there's a couple things about that story there that I find fascinating. And it's very, it's very relatable, I think, for a lot of developers.
Right.
You might be working on a large initiative for a while, but then another decision comes down the way, like, hey, we need to switch gears for a while. So you have to kind of put the work kind of on hold to some degree. And do you feel like you've developed at this point in your career a good way of kind of tracking where you're at, so that it makes it easy for you somewhat relatively simple to pick that work back up and build momentum again after the dust settles? Because I think a lot of listeners might be working in those scenarios where like they're working maybe on an overdue upgrade, or they're trying to do some migration and then something switches and then they have to put it on hold. And then they're like, oh, where were we? It's been 3 months or it's been several months. How do I gain momentum again on this?
Yeah, that's a great question. I'm not sure if I'm mastering this, but I've done that a lot. Like actually now I'm in a pause for a long running project, and I know a bit worried when I go back to it in maybe next week. But my approach, that it really works for me, though I'm not always so disciplined that I do it, but it's just writing things, like writing things down where you are and writing updates. Like Basecamp is very good for this, and we are usually at 37 Signals. We are pretty good about writing things down all the time, but I found that's the best. Like, periodic updates to the project, so that when you come back, you can just refer to those and remember where you were and gain momentum back fast. Though I have to say that I'm not always, doing this perfectly, strictly. So, and then I regret it.
Have you been involved in scenarios where you're picking up the work that someone else had been working on and trying to make sense and like having to rely on? So maybe another way I could have asked the question is like, what would you recommend to someone else, like in their career guidance? Like, but maybe it's one thing for us to tell ourselves, like, well, I always think I could be better about this, but like, if I'm giving advice to someone else, like, please go through this process, and this will make you and your coworkers' lives much easier.
Yeah, totally. I think I've done that. Yeah, not lately, but I've definitely picked other projects, and I think maybe someone has picked. I'm not sure if someone has picked my projects. At least not in this in 37 Signals, but it's just do the updates. Like Basecamp is great for this. The product, it just has this periodic check-ins. It has this new feature that we had for projects, that is the needle update. So it's called Move the Needle, and you need to say where the project is at and write an update. And it nags you a bit when it's been a while since you haven't posted an update there. So something like that, something that just nudge you to write and say where you are.
I think that's helpful. Thanks for kind of going on a little tangent with me there for our audience and for myself as well. And I just think there's always those kind of like, people might have this assumption like, well, people working on these really complex systems and applications, they figured it all out, but we're all human and we've got a lot of things distracting us. So I know I'm curious if also like with thinking about this type of scenario where you're putting things on hold, was you mentioned putting a lot of things in Basecamp. Are you also, when you're building something like Solid Q, are you opening up issues in GitHub for the project like to work against, or is it just like once you ship it, then you kind of like how did that process kind of look like if you're building out extracting something, and then you're going to then share it with the rest of the world?
Yeah, that's a great question. So we also for this we don't really use GitHub issues. We just use Basecamp. We usually use to-dos or cards or whatever there. But it's a great question because when I started, I wasn't quite sure what I have to do. I mean, I wasn't. It's not like when sometimes when our product team is building a feature and it's shaped and you have a clear vision of what you are building, and then it's easier, I think, to just write a list of to-dos of all the things you need to do and you just do them. But sometimes with solid queue, some of the in when it was early, the to-dos were very vague,
Hmm.
like figure out and queue jobs or run jobs or whatever. So I didn't quite track the work that way. I will just have a goal and I will try to do it, and then I will just write an update about that goal. But sometimes it wasn't until I got real with this, actually shipping code, that I started getting more traction. In the beginning, I remember I struggled a bit with this because was, it's sort of the blank page block. Like I got a bit of that, and I still do.
Yeah.
When I need to start, it takes me some time and it's hard. I try to write even long form, like I need to do this in a long form writing, not to do's, because I find it very hard. But then once I've got real, I have something working and I can see small steps, then I start doing. In my case, I do always to do's, and yeah, so I write there everything and try to divide them. But sometimes some to do's end up being super big. Um, and others are very small. And then I may do a pull request that closes a few to dos, or I need multiple pull requests for one single to do sometimes. So it depends. But I don't have the like a super. I would love to have as perfect, effective, a flawless procedure to do this in a structured way. But
I think that's just I think we're all trying to figure out how to find our own momentum or make progress and show progress and keep ourselves on track at sometimes. And when you're working on something new like that or replacing something like Rescue, and you're like, all right, so there's some, I'm assuming there was some feature parity that you needed to think
yeah,
about.
yeah, yeah.
Did you approach it with like a lot of a test driven approach where like you kind of like, it needs to do this, needs to do this, and like you could map it out that way and be like, until this is all green, it's not really working? Or is it just like a little piece by piece? And like, I think you probably have to play around a little bit and experiment, I would imagine, as well.
Yeah, totally. In my case, I think this part was easy, sort of, because it came given by the jobs I have to move. So basically, I was moving jobs, and then I will try to move certain jobs that will need a specific feature. Like they will need perhaps I don't know, they will need the concurrency controls, or they will need something that we still didn't have. So that was my next goal, build this so I can move those jobs.
So I'm curious, did anything get tricky with retries or serialization?
With retries, not quite. The only thing that got tricky was that in the beginning, we didn't have a way to retry jobs other than going to the Rails console and just search for the jobs there if they fail and just retry them manually. And that wasn't very nice for when you were like, we have to write up some alerts. So, like, how would you know that they fail at all? Like, unless you are checking. So we put together a very simple alert that will just check we had a separate table for failures. So the alert was as simple as checking that table and see if there is anything. It's very similar to what we had with Resque. Like, it has the failed jobs stored separately in Redis. So you just check there and see if there is anything. And so but then you have to go to the console. And that's where mission control jobs came. Like, we already had it, but it didn't support solid queue. So I actually have to stop doing anything else with solid queue until we have mission control running and you could see the jobs fail there and you could retry them there. Because it was otherwise, for anyone on call or anyone seeing anything failing, it was a pain just having to go to the database to inspect the failure and everything.
For those listening that might not be that familiar with mission control, can you explain that a little bit?
Yeah, it's a very simple dashboard to manage your jobs. You can inspect queues, the jobs that are in progress, the jobs that are already finished, if you are storing those, and the jobs that had failed, and you can discard jobs that had failed. You can retry them. All the basic stuff that you usually need to do when you are intervening manually. Because I assume, like, you can have, of course, automatic retries and all that ActiveJob has for free, but there are cases where you need manual intervention.
Nice. This episode of On Rails is brought to you by Strong Params, enterprise-grade input filtering built right in. Before strong parameters, any user could post whatever they wanted, and your models would just take it, no questions asked. With strong params, you define exactly what's allowed, no more mystery fields, no more surprise admin accounts, just peace of mind. Trusted by Rails developers everywhere since version 4.0. Strong params, because params require a user permit, is the grown-up thing to do. And kind of want to touch back on the migration process, and you mentioned that you would start moving certain jobs over as you had the capabilities in solid queue to do that with, but then at some point you might have needed to make the switch, or did you just get to a point where you'd let everything that was still kind of maybe in the rescue world finish? You mentioned that you have, like, in the future type scheduling going on, or did you ever port any of those over, or did you just let them finish out and then at some point you could turn it off?
Yeah, that's a great question. I actually moved them all. Like, I moved them manually. All the ones that were scheduled in the future, meaning I remember I did like a couple of hours in the future, because jobs scheduled in the future in both Rescue and Solid Queue, they also include retries. Don't know if in ActiveJob you can retry with delay. So you are not, like, imagine you got rate limit or whatever, and you don't want to be slamming the whatever thing you are hitting all the time. So you have the option to retry a number of times and add some delay. So it may happen that we have jobs doing that case. So I remember I migrate something like, more than 12 hours in the future, but I migrate all of them to solid queue at some point. Once we have once we have those jobs running in solid queue, so that new jobs will be enqueued in solid queue, I then move all the ones in rescue.
What did that migration process look like then? Were you pulling stuff out and just sticking in the new?
Yeah, pretty much. It's very simple. It's just a little bit strange because Rescue uses a very weird, like, the API to interact with Rescue is a bit strange. So it doesn't feel super intuitive to use, but it's simple. You just need to look how it's done. And basically, what I did, we had at a point, I think we have about 30 million jobs or something like that. So what we did was to we had less in rescue, because we also had our own homemade system to schedule jobs in the future that was using the database. So in that case, it was just a matter of copying between two different tables. But for rescue, we also have a bunch there. So it was just fetching jobs and inserting them in bulk in solid queue, basically.
So the process was like just extracting it, moving it over, and then were you just deleting it in rescue then?
Yeah,
Okay.
yeah.
And did you have to manipulate much about like what you were getting out of rescue before you could stick it into?
We use ActiveJob for that, but yeah, you need, because rescue uses its own serialization.
Hmm.
But you can just use the same way as rescue enqueues jobs, and the rescue adapter in Rails. You can just use that.
Interesting.
I don't know if it's public API or not, but it didn't matter because it was just one time.
Did anyone on your team ever share any of like what that might have looked like for people? Because like if people are listening, they're like, oh, I might be interested in migrating, but like we're gonna have to figure out how to reverse engineer these two different things. And
Right. Yeah, good question. I don't think we've ever done it, but I will go and find those scripts, and because they are in GitHub, like we had it in Git for sure. I probably deleted them already, but they are in the history, so I can totally find them.
I think that would be interesting for people to get a chance to look at, because I think that is always that, because that ends up being, I mean, if in your situation, you were building the solid queue and then you're moving things over, but like sometimes it's that middle little layer, that temporary thing you need to write to move things. That's like people are like, all right, but that's the work I need to do. Is like I don't have to build solid queue, but I might be interested in moving. But how big of a lift is that going to be? And if there was some code out there that could maybe, or at least some patterns people could kind of follow, I think that would demystify it, and maybe potentially a lot more people would get to migrate through it sooner if they're like, oh, that's actually not so complicated.
Yeah, for sure.
That's good to hear.
Yeah, totally.
And so you were able to move them over and then turn rescue off then, and you didn't necessarily just have to keep them running.
Yeah, that's right. So for the scheduled jobs in the future, we did that. For anything else,
Okay.
we just wait.
Just for scheduling. Okay.
Because those were just the jobs that are ready to be run. Are usually very fast. So as we were moving specific jobs, like the active job, changing the adapter, deploying, and making sure that they were running in solid queue, all new ones, and then seeing if we had moved all the jobs running in a specific queue, we will just remove that queue from the rescue configuration, and that's it.
Awesome. One of the things I was looking at, the source code and the README on GitHub for Solid Queue, and I'll include links to this in the show notes for everybody as well. But one of the things I kind of caught my attention is just how job state is so transparent in Solid Queue, like waiting, scheduled, running, failed, all right there in your database. So you mentioned mission control maybe takes advantage of that. How has that changed the way your team thinks about debugging or monitoring jobs now?
It's been so much easier. Like honestly, it's been really, really easy. Like we had a case actually when we were about 60% or so, or 50%. I don't remember, even less. Like of jobs move, and we had an issue where we were seeing lots and lots of jobs being enqueued of a specific type, like lots, and we didn't know what was going on. And with solid queue, it was so much easier to inspect the data, and then once we figured out what was happening, it was a really crazy thing with an automatic scanner that we were running, and we were basically DDoSing ourselves. But anyway, once we found that, cleaning that was so much simpler than with rescue, because rescue has a very weird API, and it's hard to, for example, in rescue, it's very hard in a queue to fetch jobs of a specific class because they are stored in a Redis list. So you don't have in a database, you just can just filter via column value or whatever. It's so much simpler.
Yep, that does seem a lot simpler.
Yeah, it was super simple.
So there are a few questions I think our listeners would be curious about that aren't necessarily specific to Solid Queue. And you kind of touched on this a little bit already, but I want to talk a little bit more about how your team currently approaches certain job patterns. And how do you think about the trade-offs between enqueuing batches of jobs versus, say, triggering one of them at a time?
Yeah, that's a good question. I'm not quite sure we have like an official answer to that. I think we usually think of different possibilities. For example, if you are going to do, like, you mean a batch of actions in the same job when you say, or enqueuing a whole batch at once, or enqueuing one job in that batch one by one, or Just making sure I understood your question.
Yeah, no, that's a good follow up there. I think from my experience, I've seen a lot of teams either go through the route of being like, all right, we're going to have something that's going to queue up 1,000 jobs individual, and then maybe some of those will queue up some, or we're going to have like a job that's going to process 1,000 things as one job, and then there's kind of like this chain effect, or like, well, then maybe that spins off another job, and it keeps cascading a little bit, and so.
Okay, got it. Yeah. So I think what we will do will be to try to keep jobs the smallest you can, in a way that it makes sense for the action to happen independently from the other actions. Like, say, for example, those 1,000 jobs, those 1,000 things you need to do, say they are completely independent. They aren't related. So then in that case, we will go for different jobs because it'll be faster and it'll be also much easier to retry. Like if we have to say that huge job fails, you will need to ensure that it's reentrant, like you don't process the same things over, or that if you do, it's okay, and all those things. So it will be much easier. The problem is if the specific things, maybe they depend one in other. Like, you have a bunch of things you need to do and they need to be done. Like one needs to happen only if the previous one needs to happen, and so on. So I know there are different opinions on that. I personally, I don't like to orchestrate these kind of things using the jobs to do the orchestration. Like, I don't like to have jobs that depend on other jobs to run. I know some people like they have this. Actually, Solid Queue doesn't have this feature yet. People want it, like to have that sort of flow that you can do, or batches. Like, you need to run all these operations and then that triggers another job and all that. We don't have that yet. The main reason we don't have it is because we don't use it. So we didn't build it. The truth is that I don't like that very much because it becomes very hard to debug. I find it very hard to troubleshoot when you use your job system as the orchestrator. I find it simpler if I do that in the code. I use a single job and then I make sure I can retry that job and I can resume that job if it needs to, like if it fails or needs to be resumed. And actually, we are going to, a small sneak peek, we are going to open source a very simple solution, very, very nice, that we put together in my team. It was Donald, who worked on Solid Cache. He worked on this. And a very simple solution to easily interrupt and resume jobs. That could be, these kind of jobs that do a lot and can be interrupted, and you need to be sure that you can resume them. So you don't need to use independent jobs that need to be running, in a specific sequence and depending on other jobs. So this is going to be, I don't know, soon, I think. I hope.
That's interesting. I'm always thinking about, with how teams are trying to approach that with their different things. So maybe there's trying to think about maybe we can talk about a specific type of reason why you would have like maybe some sort of job that's maybe it's a scheduled or recurring thing, things that maybe many years ago we might have used cron for, to like, okay, every morning we need to generate a bunch of reports for every one of our customers, so that then they log into their interface, they can see some updated data from that's relatively updated or accurate, up to live data, but maybe it's not live data because it's too intensive to do it in real time. So in that sort of scenario, if it's like a daily thing, you're going to do the process for all of your customers and sequentially go through each one and do that. How would you think about approaching that today?
That I will totally use a recurring job or a cron job, totally, that enqueues jobs, independent jobs for each customer. I will totally do that. And we had another very fun incident with jobs. In Hey, we have a recycling feature. Like you can set specific contact or like a specific sender or a specific box to be recycled. That means that after 30 days, everything will be deleted. So the way we had implemented that was that we will create a recycler for a specific contact, and then the recycler will be scheduled, it will run, and then it will schedule its next run. What happened there was that some recyclers, for some reason that we weren't sure because it was long before and we didn't have any logs anymore, they were failing to enqueue maybe something, I don't know, maybe there was an issue with Redis, there was an issue before, whatever, but they failed to enqueue their next run. What happens there is that you just lost the recycling completely, like they stopped and you don't know. And this can never happen if you have a recurring job daily, because if something goes wrong one day, you know that then the following day it's going to run again. And whatever happens is going to, it's going to be remediated in a way. So for this case, for the case of the reports, maybe you want to make sure that you get alerted or whatever if the reports are not delivered. And for that, I would probably track that information somewhere that say delivered, true or whatever, something like that. But I will go for the simpler, like, as I say, it's just hard to account for all the things that can go wrong. If you are assuming enqueuing jobs is going to always be fine. Like, you need to assume that enqueuing jobs may fail.
Yep.
Like anything that may fail. So you need to, I think you need to account for that. It may not matter, like it may be a job that doesn't really matter much. Like maybe, I don't know, some turbo stream jobs, for example, that if you use turbo, you get those. Some of them may not matter because it's just a update in the UI that it doesn't have any big consequences for the data. Like no data is being lost, no action is being interrupted. Like it's just an UI blip, like if you reload the page, it's going to be there, whatever. But there are cases that you do need to think what happens if your jobs are not enqueued.
So a couple of things that to extract out of that. And so you're not a proponent of having jobs scheduled the next time that they should run.
No.
So what do you think in that scenario should be triggering that? What is kind of like the kind of current modern day approach to that? And or does your team still use cron type stuff anymore, or are you using? Yeah.
Yeah, we do. And actually for the stuff that we don't, like the incinerations, I really want to move them to Chrome, because just last week or 2 weeks ago, we have a edge case where in Basecamp, when you deleted an event from the calendar that corresponded to a recurring event and wasn't the first event in the series or the last event in the series, so it was a middle recurring occurrence, you deleted that, it went to the trash, and it will just stay there forever. Because we weren't currently enqueuing, like it was like the logic was so complicated that we weren't enqueuing the incineration job for that case. And that just doesn't happen if you just have some record in your database that says this needs to be deleted and is due on whenever. And then you just have a Chrome job that checks everything that is due and does the work. And so if you miss it, the next time it will be available. I find it so much simpler than just relying, on enqueuing those jobs in the future and all that. So yes, we do use those, and I want to move those incinerations. I really want to move them to this model because it's much simpler.
And it's always been there.
Yeah, exactly. It's just a simpler thing. It's just the truth is that sometimes I love simpler solutions that have always worked fine.
It's such a good point there, and I think that's one of the things I've appreciated the last few years within the Rails community is that we're getting in touch with. I'm like, wait, that was what we were doing. We had to do that 20 years ago. So I think there's like anything like there's some types of technology, like using cron as an example. It's been around forever, and it's such a reliable thing. But then at the same time, and it doesn't feel modern. And so why do you think engineers build these new approaches to?
Right.
It's like, well, let's not trust that the computer is going to be good about remembering what time it is or something, and like, which we hope it does. But that also in a certain way, I think it feels like, I think people might be listening like, well, I think when you run things by cron, it feels like you have a little less visibility into what's happening, and so maybe there's a trade-off that people are.
Yeah, totally. So for that, actually, we had cron jobs built into SolidQ. Like I say we use cron jobs. We call them cron jobs, but they don't run with Unix Chrome, because that was actually a thing we had to do because of Kamal. Resque has a plugin called Resque Scheduler that allows you to schedule jobs in the future, because Resque by itself doesn't have this. But that Resque Scheduler also has Chrome or recurring job thing, where you can define jobs that run recurrently. And so with Kamal, it wasn't that easy to run Chrome in the Docker container. So we have to move. We had real cron jobs using Unix Chrome, but we have to move them to Resque Resque Scheduler. So then when building SolidQ, we needed a replacement for that. So SolidQ actually has recurring jobs, which are like cron, but it's just they are defined in a YAML file and run automatically by SolidQ. So yes.
Okay, so that's helpful. Thanks for kind of explaining that.
Yeah. Doesn't need to be Unix cron. Just the general model of having a recurring thing rather than something that needs to schedule itself and
Right.
or something that you need to schedule in the future and trust that whatever it's also especially super useful when there is something that can change a state. For example, trashing things is very easy to see because you trash an item in Basecamp, and so it goes to the trash, and you enqueue the job 30 days from now, for example, to delete it, and then you restore it because you change your mind, and so you enqueue that job is not valid anymore, but it's there, and then you trash it again, and so you enqueue another job, and now you have 2 jobs there in queue that will do nothing, but it's just it gets wasteful in a way. Like, why do you need to have to account in the jobs? Of course, you need to account that do nothing if the actual thing is not trashed anymore, because otherwise you would be losing data. So it's also all those things that get so much simpler if you just have a process that checks everything that's deleted and just delete in that moment.
Right. And just for kind of dig into that, I'm going to ask a couple maybe dumb questions here, but like just to make sure I understand the difference for our audience here. So you might have a job. Let's take that job, like you're deleting something, and so you create a job, schedule a job in 30 days or whatever. Like the plan is in 30 days we got to delete all of this stuff for real. Now it's like a soft delete, and we're gonna like maybe permanently remove it or whatever. And that job. One approach could be that in that job, when it starts to run, it will check, is this still something you should be deleting? Like that should be, is this still in a state that you should be doing?
Right. Yeah.
Maybe another curiosity here is like, what happens when the business logic changes between now and 30 days from now, where...
Yes, exactly. We've had that problem. What happens there is that you may get a lot of errors for some reason. Like imagine you change the 30 days, right?
Yeah.
So we have that. That's the case. The logic is as simple as you say. Like basically in a deletion job, we check if the record is still trash, no? And then we delete it. And if it's not, we just do nothing. So the job runs. But then if you change the date, say that because also you don't want to, it's not enough to check if the object is still deleted. You need to check if it's been deleted for enough time, right? Because say you delete something, you restore it, and then 1 week later, you trash it again, right? So then you will have 2 jobs, one running in 3 weeks and from the second deletion, and one running in 4 weeks or 30 days or whatever. So when the job in 30 days come, it shouldn't do, even though the record is in the trash, you don't want to delete it because it hasn't been 30 days. It has been 30 days since the first time, but not the second. So you need to check that. If it's, we have basically what we check is that, is it due for deletion? That would be the check. If it's due. And if it's not due, we wouldn't do anything. Or in some other cases, we may raise an error. It depends. So if you raise an error and you change, it happened to us. If you change the period, it may happen that your records that are actually due for deletion, they are not anymore because, when that date comes, because you've changed the period. So then you will have all those jobs erroring, or if they are not erroring, they may just do nothing, and then the records will be there forever. Because you need to make sure that when you change the logic, you will need to schedule new jobs for everything that had already their jobs scheduled. You know what I mean?
Yeah.
It's so much complicated, so much more complicated.
Yeah.
Whereas with the recurring approach, you don't need to worry at all. You just change the logic, track the date where each record has been deleted, of course, just the last time. You only care about the last time a record was deleted. And so when the recurring job comes, when the current period, you just check it, and if it's not due, you don't need to do anything. But also, it will come in the future. And if you make the period shorter, everything that wasn't due before, maybe it'll be due the next day, but that will be fine. Everything will get the new period immediately applied, if that makes sense.
Yeah. And, in that scenario, so you're maybe flagging like a column or something that like this needs to be deleted at or sometime.
Yeah, exactly.
And then, so on that date, it will check for anything that matches that current date.
Right.
And be like, okay, this must be, and then you put it in the job, and then the job itself also then double checks, I would imagine. Do you do that?
Yeah.
That the state still is what it's supposed to be. And so I think so there's nothing happening. There's not something sitting around waiting for 30 days, right? It's just...
Right. Yeah, that would be, I mean, we still do the scheduling in the future. Like, we haven't migrated that. Speaking, saying all those things aloud made me, just finishing this podcast and just go and migrate, because it's just so much simpler.
When they think about retries in particular, because jobs can fail fairly unpredictably at times. And you mentioned something about how you could interrupt and resume. Like there might be something coming down. Like, can you give me like a example or when you would want to do that, or what? Like,
Yeah, so for example, one good reason for that is that, Kamal, when the way it works, when you deploy, you have a grace period for the running containers to stop. And they stop, and then the new ones start. And with Kamal, you are not allowed to have two versions of the code running simultaneously for like ever. Like, they don't run simultaneously. Only for that grace period while one is stopping and one is starting. So that means that you may have jobs that are very long. For example, in our case, one of our longest jobs are exports. People can export their data in Hey and in Basecamp, and depending on how much data you have, it may take a while. Like, it may take hours. If you have a very big account and you are exporting everything, since you can upload files and it can take hours. So that's a good example that if we deploy and interrupt that, it will be really, really annoying to have to need to start again from the beginning. And then imagine if we are working, if it's a weekday and we are working and deploying often, you could have the case of an export never finish because we are just interrupting it and it needs to start. So that will be a good case. You want to run, and if you fail, you ideally you should be keeping your state when you were interrupted, and then when that job starts again, you just can resume. It can be export, but it can be any other kind of long running job for things you need to do.
That's another good example there where I'm assuming with like an export, you're not just adding a bunch of new data into the database. You're maybe literally exporting files to somewhere, to some server or something.
Right.
And like if that process were to get interrupted or stop halfway in the middle, and then and it has to restart. If the job fails, like how do you think about patterns for cleaning up what had already been generated, or do you kind of approach like check if something is already, like if these files already exist, we'll just keep using them, or like what does that look like there?
Yeah. In the case of exports, it's actually very simple what we do. When the export starts, we store a sort of file with a token thing where we store some information about the export itself. We keep exports as records in the database, so we can track the status. Like, we know if this is pending, if this is resuming or ready to resume, or if it was interrupted. So we track that there, and then we store a little file in the place. We have like a sandboxed, it's like a separate volume that we mount in the export container. We use a different volume for that we mount in the Docker container where the export jobs run. And so we create a folder for each export and we store a little file there. So when the job starts again, it just checks if it's running there. Actually, we had a way to force. We use a feature with ActiveJob that you can use different queue names. And we have a little hack. Actually, we should publish this because it's very clever. It was invented this idea was by, I think, Jamie's or Jeremy or whatever in my team had this idea. But we use the queue name to make sure that all export jobs in a specific queue run always in a specific server, in a specific VM. So we know the volume is there. So there is not like the next time the job is going to run, it's going to be picked by a different server. And of course, the files won't be there. No, we ensure it goes there. But also, if you have just one server, you don't need to worry about this because it will be that. So, and so we store that little file. And when it starts, it checks that is there. And the progress, we store the progress there. And we just see where we were at. There are other techniques. Maybe you could also track it in the database, perhaps, like at certain points, I've done this. So it doesn't need to be like a file there, but it's what we do.
Thanks for kind of diving into that. I think that's helpful to get some context for some of the lower level details that people might be trying to figure out. Like, how would we approach that? Tell us a little bit more about how you think about testing background jobs.
Yeah, so usually what we do for jobs, this is something that I wasn't doing before joining 37 Signals. It was something I totally learned there. And it's that they, at 37 Signals, they advocate for having almost no logic at all in the job. If you look at our jobs themselves, they are tiny. They are usually one line, the perform method. So actually the job logic is one thing, most cases, or two things, three things. And so that logic, we always put it in the model that's there. So test the model for the job logic itself. Then, of course, is the matter of testing situations where the job may be wrong, when you can't get errors, what happened, the retries. That usually we use testing helpers that ActiveJob has. Maybe not everyone is familiar with those, but ActiveJob includes some really, really handy helpers that allow you to check if a job was in queue with the arguments, the time, which, in case it's a retry, you can check that it was enqueued with the delay that you expect it to be enqueued. So that's super, it's actually for us, it's been enough. But it's true that sometimes we've added tests for that once we had a problem with a job that, wasn't being retried as it should. We discovered it, we fixed it, and then we added the test. And lately, I don't know if you've seen this, but Stephen Marheim, I'm not sure if I'm pronouncing his surname correctly, but he's the SQLite guy. So he published a gem. He has a gem that's called Acidic Job, and he has another gem that is called a Chaotic Job, I think. But it has like lot of really, really cool methods for testing jobs and simulating a lot of scenarios, like this job, and introducing random errors.
Interesting.
Like a chaotic job is this sort of chaos monkey that is supposed to go in your infrastructure and your system and just cause random problems. So he did this for jobs, and it's super, super neat. I saw a talk from him explaining how it works, and it's really, really neat. We are not using that, but I think that has a lot of potential for us, for everyone.
I think I'll definitely include links for Steven's gems in the show notes for everybody as well, so we can look at that. What was the first one? You mentioned chaotic job, and
one is acidic job for sure, and the other one is, I think it's chaotic job, but I'm not completely sure because I'm speaking from memory, but it should be super easy to find.
Great. I'll definitely track those down for everybody. And you mentioned earlier, I'm curious about another maybe things that you tested out with you mentioned you might have already removed the code, but for that migration from moving jobs from Resque into solid queue, where did you stick the logic for that? Was that like, was it more than like a rake test that you just ran on the server, or is this something?
In that case, it was just that because it wasn't very complicated. Just a rake test I ran in the server. Well, first I did some tests manually, just in the console, checking that I wasn't breaking anything. And then always, without deleting anything. At the first time I did that, I didn't delete the jobs. I deleted them only when I was sure that they had been correctly moved. But that case was just a simple task. In other cases where it's been a little more complicated, I may have create a simple Ruby object, a class, and sometimes I add tests for that if the logic gets complicated. Like in that particular case, I didn't because it was just copy this here, that's it. But some cases, some more complicated migrations we've done, we do that. We just create a regular class, we add tests, and yeah, we will use a rake task from the server, just using that code that we will have deployed beforehand.
Okay. So it sounds like something that I've talked about with people, like with teams, is like a lot of teams, because I work on a lot of projects where they've been around for a while, and then we'll come into them and we're like, or trying to make sense of like what code is still worth keeping, or what still needs to be around. So does your team have a healthy approach for removing? It sounds like you mentioned to remove that code maybe from the project that it's since been deleted. So what's that process look like? Or is it kind of like an informal, like, we don't need that anymore, let's just go ahead and remove it?
Yeah, it's sort of that. Like we don't have a really, like sometimes I think we keep some stuff that could be removed and is still there. In this case, it was because I was, it was some sort of culmination of moving from Resque to solid queue, a culmination of deleting everything rescue related, everything deleted. And it was so satisfying. But but in other cases, I'm sure we have some migration scripts that don't make any sense anymore. And they are just there.
It's just such an interesting thing. Like you mentioned, like it's like that code's still in Git technically, but I'm always, and people are like, well, if we delete it, then someone could track it down. But I'm like, what about the person that joins in 5 years from now? Like they're never gonna find that, and maybe that's a great thing, and so I think there's sometimes teams or developers are a little precious about keeping their code around, and it's also like we can figure this out again one day, or it's just like, how will we need to re-reference this or not? And so I don't think about how teams could be a little bit more proactive about like, let's delete this stuff. Like nobody needs to see, like, it's because it's there, and it's getting accounted for every time we run our, getting stats on how big our application is or our test coverage. And it's like, let's just delete the stuff. Come on, it's okay.
Yeah, I love deleting things. I'm very easy to delete, but I'm also good at writing things down. So usually, for example, in that case, I wrote that somewhere in the to do to delete all the last stuff. I probably linked that and made it, that you can search for that in the future if you need to know, and that will have a link to the pull request, and then you can see how it look before being deleted.
Yeah.
But so I'm one for delete, delete, delete.
You hear that, everybody? Rosa says to delete some code. Go do it today.
Yes.
Do you often delete other people's code very often, though? Or do you think in that scenario is because if you had written it, it'd make it a lot easier?
Yeah, it's true. I think, I mean, it depends. But I think I will delete everyone's code. Yeah. Now, at this point, I've been at the company for 8 years. So it's not the same like if you are new. maybe I will be, more shy about deleting things. Like I wouldn't be, uh, doing that. But
Yeah.
in that sense, I don't think anyone at my company is very precious about that. So that's also a factor. Like if I was in a different company where people were more, prone to keep things, I will just keep things. I wouldn't be, trying to impose my view and deleting everyone's code. And, it will depend.
I'm going to keep advocating that we should probably delete more code.
Yes, me
So
too.
I think it would be just better for everybody. Okay. For teams listening and thinking about maybe moving from Rescue or Sidekick to Solid Queue, what would you want them to think about ahead of time?
I think the main thing perhaps will be to get volumes, like to get some numbers. Like how many jobs are you enqueuing at peak? What types? Like how long can they be delayed? All your numbers, your restrictions, and all that. And then just do some calculations with the hardware they have and the database they have, just to make sure that they are not trying to move to a database that is too small, maybe, and then running into trouble. That's what I would do, I suppose.
Okay. And was there anything you maybe would think about doing differently if you had to do that migration again?
Yes, one thing for sure, like the main one, will be to start from the beginning with a separate database, because we started with the same database as the application, and we discovered later on that we couldn't do that because it was just for a specific type of jobs we had to enqueue them using concurrency controls. That is a feature of Solid Queue to ensure that some jobs they don't overlap when they are being enqueued. I'm not a fan of this feature. That is my most hated feature of Solid Queue. It's the trickiest one of them. I'm not super happy with how it works, but it was the best I could come up with. I couldn't come up with something better that didn't hurt the polling like the regular operation. So I'm not a fan. It has a lot of overhead. It needs a lot of writes in the database. It's not for this kind of feature. Redis is great. Like when you have the TTL, the kind of log that you can implement in Redis to make sure that it only set this key if it's not set, and to implement logs is so nice. Like and the expiration as well. Like you get it for free. For this, the database is not great, but we needed this feature, so I have to do it. Anyway, it's what it is. But the thing is that when we had some jobs that were we had a lot of them, and we have to move them, and we saw the amount of writes we will have to do in our app database. And so one person from the SRE team and we got together and made some calculations, and we thought that was kind of risky suddenly to put all that write load in the main database. So that was when we said, okay, we need to move to another database. And that was just much more complicated. Like to have that was way harder than having Rescue and Solid Queue together, it was much worse to have solid queue in one database and in another database. Like that's what, so I will definitely start with a separate database from the beginning, and I will save myself from that.
What are you most proud of from this migration?
That we didn't have basically almost any customer impact. And I say almost because there was customer impact once, but it wasn't because of solid queue. It was a mistake I made, not related to solid queue. It was a mistake I made with Kamal. With Kamal, you needed to run some MV5 thing that I forgot to run, whatever. And so I caused a small outage. It wasn't an outage, it was just some actions will get a 500 error. But that was the single one, the single customer facing issue we had throughout all the migration. So I'm proud of that. We had other issues that weren't customer facing, but still, a customer facing is the most important thing. So
Sure. That's wonderful. All right. So before we wrap up, I want to ask you a couple of last questions here, Rosa. And do you have a software book that you find yourself recommending to peers?
yeah, I think so. I got one here that I got it from my shelf. It's one that is a bit old, but it's Refactoring from Martin Fowler. This book
Yes.
was.
I have it right there.
Ah, nice. So DHH is a big fan of this book, and when it was released a few years ago, 37 Signals bought it for all the programmers in the company. So that was when I got it, and I think it's really nice. And the other one was one that I got recently. Is this one? It's genetics from Gerger Lee Oros. He's very famous guy, and it's a pretty nice book about software engineering in general. It's from the Pragmatic Engineer, the software engineer's guidebook. I think it's pretty nice.
Nice. What I'm trying to remember, is that version of refactoring the one that's all in Java, or is that the
I think it's using JavaScript.
JavaScript? Okay. Remember the
yeah, JavaScript. I was remembering correctly.
Okay, yeah. The original one was all in Java, but
Java, yes.
I got familiar with that book right when I started using Ruby on Rails, and that was like 2004, 2005. But it was given to me as a gift from someone, and definitely got me really excited about wanting to improve existing code. And I was like, wow, okay, this is interesting. Do you find yourself referencing that quite a bit?
Sometimes I think about it, but not really when refactoring. That's the funny thing. That is sometimes thinking when writing code, like new code, I sometimes think, okay, I could do this in this way, use, for example, like a different method here or whatever. And thinking that this is how it would look if I had refactoring this, not writing from scratch, but refactoring it from some fictional other code that I didn't exist, applying this refactoring.
Curiosity, do you often do much like pseudocoding? Like, I wish I could express this concept like this, and then figure out how to and like from like a style or a taste perspective. Like, Ruby allows us to do a lot to be expressive in with our programming, and I know it's probably sounds like something that seems to be really important to David. But how do you kind of think about that?
I don't find myself writing pseudocode much often.
Okay.
I only do it for higher level when I need to do a task that is complex. So I write it down what it needs to happen, but it's not. I wouldn't call that pseudocode because it's higher level, I think.
I didn't mean to imply that David does pseudocode. I actually don't know if he writes pseudocode, but yeah, I don't know that. I think of more of like, if I'm like, you're working on solid queue and you're like, how am I going to interface with this?
I see what you mean.
Thing, you're like, how might I lay this out, or a little bit like, what would be a nice way to interact with something, and then not worry about behind the scenes yet, but like, this is how I want to interface with this type of entity.
Yeah, I see what you mean. Yeah, I see what you mean. Yeah, that's a good question. I think I may just think in my head how the API will look like, and then try to write it a little bit, but directly using Ruby. Like, yeah, I will just use Ruby, but I will try to write that first. Like how the interaction will be, and trying to imagine how if I was the person using it, not writing it. So just writing it. I think I will do that. But I also realized that I don't do that a lot of consciously. I just now I just I didn't think consciously about that.
Just kind of happens. All right. Well, where's the best place for folks to follow your work or dig into your writing online?
I don't do a lot of writing online. I'm sorry. I think the best for all this kind of stuff, it will be the development blog in 37 Signals.
Okay.
That is where I've been publishing everything that's to do with Solid Q, but it's been very little. I know this is one of the things that I was hoping to get better this year, but I don't think it's happening this year. I think it will be a 2026 resolution.
Okay. And, I know that you've given a number of talks as well. And are those included on your own website or?
Not yet, but they are in the wonderful Ruby video site. It's great. It's been renamed to Ruby Events.
Oh, yeah.
And all the talks are there. And it's super nice because it saved me from having to list those in my own website. I can just send people there. Yeah, it's really cool. It's really nice.
That's great. Well, thanks for that. I will include links to those as well for all of our listeners. Rosa, thank you so much for joining us on Rails.
Oh no, thanks to you. Thanks to you.
It was really great to hear how your team approached the move to SolidQ and all the thought that went into making it work in production. So really appreciate you sharing all those details with us and diving into the deep end with us. Thank you.
Thanks to you.
That's it for this episode of On Rails. This podcast is produced by the Rails Foundation with support from its core and contributing members. If you enjoyed the ride, leave a quick review on Apple Podcasts, Spotify, or YouTube. It helps more folks find the show. Again, I'm Robby Russell. Thanks for riding along. See you next time.